Respected Chairman, distinguished guests, and my dear spatial colleagues, I deem it a great privilege to have an opportunity to present my topic of today towards a groundwater spatial data infrastructure. I'm going to talk about a story how I underwent within 3 years of working in a private sector and working in the government as a client, that we spatial professionals would go there and just do the SDI and implement it very successfully on partnership with the government, because government is quite important to legislate and do things, whereas in Australian environment that you take up ideas to the government as a private sector, and we work together to make things come true for the benefits of the taxpayers. So here is what it started when I joined SKM, which is a private company in Australia, and it's globally present, and it's also present here in Malaysia as well. So typically our groundwater colleagues like to manage their data using spreadsheets. They allow and they want to control their data, and they would like to manage. No disrespect to them, but that's how they would like to manage their data sets. So basically you have the location of the data, but also you have metadata information and cost summary. And once the project goes at a national scale, managing spreadsheets, you and I know that it's going to be difficult. Then we moved to a model where I could convince them, okay, let's take from the spreadsheets towards a small database where people are able to reference all information related to the borewells. And that's what we came up with, an access system with reports, drillers' logs, geologists' logs, pretty pictures of the borewells, all at one access point so that they would be able to access information at their will and probably provide more hyperlinks. So this is an evolution of getting the data in a structured way, be able to query and analyze for decision makers, but also be able to converge all these spreadsheets into one particular fashion. Then they required more information across, okay, we do have it in the database, but we need to go and monitor in the field and get accurate information, because water data is dynamic, but it's also about the associated assets across the groundwater that they need to monitor, like their, the electrical utilities, the cables, and all measurement system related to the groundwater. So we developed here a system, a mobile mapping with a concept of a database where people able to take the mobile devices, measure, come back, synchronize, and still be able to generate reports automatically or semi-automatically to this structure. Then came an opportunity for us to develop a state-based borewell database for the state of Victoria in Australia. So, well, we do have Excel sheets, but I think there's a lot of powerful in the GIS, so why don't we think about spatial enablement? But here it's not only about the location of borewells, but it's also about the stratigraphy information of each borewell, so that people are able to interpret that stratigraphy information and then transform that information into useful geospatial surfaces and then volumes. At the end of the day, we would have all aquifers mapped in the three-dimensional with this concept. So we presented this idea to the client, and they liked it, and then said, well, we want you to do this project, and that's how we progressed. I'd like to highlight over here, at this part over here is, we as spatial professionals are not domain experts. All that we have to do is to provide tools to the domain experts, the ecologists, biologists, or the hydrogeologists. So what we need to do is give them access to the data, and we always complain the quality of data, provide measures in the system so that they are able to produce good data quality products. All our investment went into building this interface. Sorry. building this interface where people are able to interpret the depth of bore wells using ancillary data all at one shot, but also people can override what the previous person has interpreted. So that means no data gets deleted, and there is a history lineage of the bore well having different interpretation of hydrogeologists, and that's throughout Victoria. And that helped us to build a quality surface beneath the ground using this data. I don't say that it's 100% accurate. There are uncertainties associated with it. Still, using that data, we could interpret those surfaces, and then the story goes on. So from an access interface, we went into a web-based interface so that other private companies who could join hands with us to interpret the whole of Victoria, because it's a big project to interpret all the bore wells in Victoria. So we need partners across to interpret, and domain experts of the local knowledge to interpret that bore information. So that's where the web system was developed, so that partners are able to contribute to the quality as well as to the structure of the project. And that's where we have the 9 aquifers mapped for the whole of Victoria using a non-spatial data set transformed into rich stratigraphy data, and then it's converted into a pretty 3D surface. So what is this information useful for? This information would be used by the hydrogeologists and water managers to convert geo-volumes so that they know exactly to govern the licensing information, the water quality, etc., with this framework. And that's what is our job as spatial professionals, is to enable this. And then it went on from the state to a national groundwater information system, which is a concept where we approached the National Water Commission with this idea of Victoria, and they said, why don't you do a prototype? Also, we would like you to include licensing information and water allocation so that the water managers are able to not only deal with the science of the aquifers, but also be able to manage water effectively. And that's evolved the story of NGIS Phase 1. We did a proof of concept, and also we worked with the Arc Hydro Groundwater Data Model, which was produced from ISRI, and that incorporated into a national GIS, and now we have completed most of the states in Victoria, and in the Phase 3 we will have a web-based access that people are able to use this information to do water allocation, licensing, and also use information in a meaningful way. That's another product on the interim groundwater data set we produced for the Australian Bureau of Meteorology. Now here comes the challenge. Once we have got the science right, we have got the bore wells right, we have interpreted the stratigraphy right, and now we have a national system, but jurisdictions, the states, will not cooperate on the terminology of the aquifers because they are all natural boundaries, our management boundaries are administrative, and they overlay with the state jurisdictions. In order to have a consistent vocabulary, we came up with this idea of the National Aquifer Framework. This is where the ontologies come across, where we got all the hydrogeologists across each state department into the room to come to a consensus of how we define our aquifers in a scientific way so that they would be managed with their physical properties as well as allocate water licensing so that they can reuse the data once we have brought it at the national level. So that's where this project, which commenced for about 6 months' time, we got these jurisdictions in the room to sit and agree upon. Everyone agreed, and that's where we populated this vocabulary information on top of this rich NGIS database. And how this would work, so we developed the tool based on the information we collected. So each state jurisdiction having their aquifer framework will be able to populate their data set and then validate with the national framework, and they get out a national compliant data through this tool. And here is another national project with links with the National Groundwater Information System. It's called the National Atlas of Groundwater Dependent Ecosystem. And why is this important? Australia is a mining country. People go left, right, do mining, and there is an impact to the groundwater. And in turn, it impacts the ecosystems which are reliant on groundwater. The studies have been done at micro level in places. So there exists no national system where the whole of the country has been mapped for identifying the dependency of ecosystems on groundwater. So SKM came up with this idea, went to the federal government and said, in order to do the mining compliance and the local governments to monitor as well as have a transparent system to monitor the ecosystem, we need to map this country. And it was a challenging task of 18 months, and here is a story of SDI implementation. We had to start from scratch. We had to get all state jurisdictions into the room where we have to discuss about how each state jurisdiction could bring along their groundwater dependent ecosystem data, and then how we would convert that into a national consistent layer so that people, the users of this system, are able to make effective decision making. 18 months, $4.5 million project. SKM was awarded in partnership with the space agency CSIRO to produce a remote sensing layer of about 10 years temporal data across evapotranspiration, which is used for the GDE mapping. And also, I had a challenge here of implementing this system in open source software. In my proposal, I said, I will use ISRI, where the government legislation came across saying, sorry, our policy is working towards a system which is totally based on open source software for people to discover, access, and implement the system. Given that we are a ISRI box and we are an ISRI company, and thanks to ISRI, they do have modules which could convert things into PostGIS, which made my life easier. So that's where the another challenge we had to make was the production system is compliant to an open source software so that people are able to access. Another attribute of this particular system is that people should be able to download the data sets and use it in their GIS, and people who do not know GIS, know Google Map, are able to use GMZ or KMZ files so that they will be able to populate this data set and view it across the Google. So we had to conform to those specifications, and the system would be online on August. As I speak, my people in Australia are rounding up the project. On 31st, we hand over to the federal government, and federal government Bureau of Metrology will be hosting this data set, and it will go live to public on 15th August. So this is where the spatial data model. And mind you, any good project comes to a fruitful preparation is that spatial data model, because not only I'm a computer engineer, but I think to have a structured approach is always good, and it's also good to get the consensus of the state jurisdictions that their data models are consistent, that data structures could be brought into a way that we are able to populate this. And it's quite important that to get an agreement of jurisdiction. Probably it worked in Australia because a private company is coordinating with the state jurisdictions, and the federal government takes a step back, and then they come into situations where policy matters come. The another important thing I had to solve during this atlas is the data licensing. And luckily, the federal government came to an initiative of about embracing this atlas across Creative Commons licensing, which made our life easier so that all this data access is covered across Creative Commons. And that's an initiative which the Bureau of Metrology kind of took the advice to implement across this particular project. So that's data model. We had 22 million polygons crunched into 4 million polygons at the end of the day, and it's all generalized, and the speed was 10 times faster initially due to producing spatial indexes and appropriate coding. Another important thing is, during the phase of the projects, we developed the whole country into 8 work packages. As and when the 8 work packages were developed, we got our state jurisdictions and the steering committee to view the quality of data to this web-enabled quality check. So as and when the work packages were ready, they were pushed into a web service using our ArcGIS server, where the comments of each jurisdictions were placed, and they would put their review comments here. So we had a transparency in the quality control of while we were producing the data set. And that's an example of how we compiled 10 years of MODIS and Landsat data to prepare a 25-meter consistent national grid in about 4 months' time. And that's an example of how when user with spatial or no spatial knowledge will be able to interact with the atlas. And this is the first atlas where people are able to do buffers online and do geoprocessing using open source technology. Some screenshots of location search. So there we have a free engine. People could type a free text, and then it will retrieve information on the GDEs. And that's where we worked out with the SDE and the Postgres environment, where we are able to update the database through the open source. So in summary, what we have as a private company, it's not that the governments have to do the role. In Australian scenario, that private companies such as us are able to have this multidisciplinary experts, where we are able to come with a conceptualization, go to the state or the federal government, and put those ideas forward, and then they come down and say, well, the government would fund, or probably the private sector would take a step here to initially fund the data acquisition, and then the government would take the custodianship of it. So through that process, following are the projects which we are involved in the NRM sector. So world's first national atlas on groundwater dependent ecosystem, the National Groundwater Information System, which covers most of the bore wells in whole of Australia into one single database, and then the National Aquifer Framework, which deals with the vocabulary. And also, we have dealt with a lot of policy issues, because it's not only about the technology. Technology is there to solve, but the main thing we need to win on implementing a successful SDI is the policy and the ability to get the consensus across the government to implement a successful system. But still, there are issues around, or the way forward I see with my own experience in the groundwater area is, now we do have the 2D surfaces. I think we need to go beyond that in order to do volume selection and volume measurement and be able to do 3D spatial queries. So for that, we need a true 3D topology so that people are able to see what's the data in the aquifer, and also ability to see the impact of drilling across the bore wells, so that the 3D queries would be able to do an effective spatial analysis. Apart from that, it creates a good visualization and improves better decision making. So 3D GIS for groundwater comprises of the 3D geometry, topology, as well as the semantics, the vocabulary I spoke about, and its appearance. So representing 3D geometry in the groundwater context from a spatial data perspective has been a challenge. Although 3D geometry has been well represented above surfaces such as 3D city GIS models, but there is a limitation on sub-features such as groundwater data in 3D geometry. There are data models such as arc hydro groundwater, which are 2.5 dimension. However, with true 3D topology from a spatial database perspective has to be explored. And by representing true 3D geometry, we'll be able to do 3D spatial analysis, as I said, and also better visualization. And absence of remote sensors across the subsurface is a bit of problem because there are uncertainties associated with the interpretation. Now I am told that there are sensors available which could go along with the bore well, and we need to work out the costing of it so that we are able to reduce the uncertainty there. Another interesting problem is around the spatial semantics. Once again, the vocabulary, the physical properties of the aquifers, which needs to be consistently agreed upon, and that's where we will get the ontologies from the computing world to the real spatial world there. So we are here in Malaysia since 1970, and I'm proud to say that we have been involved in the design of this convention center as well. So we are 300 strong people in Malaysia, and we are trying to get our geospatial capabilities and the knowledge transferred, what we acquired from Australia to other places in the world through our local colleagues here. So I'd like to take this opportunity to thank the organizers, especially Dr. Kadir and Madam Fauzia, for giving me the opportunity to meet you all and share my experiences along with it. So I think to build a sustainable water resources using strength of spatial information is very critical. Many thanks for your patience listening. Thank you.